So we'll just talk real quick about the test. There are some statistics for the test here on the whiteboard. And I want to remind you that according to the policy in the syllabus, if you do better on test number 2 than you did on this test that you just got right here, I will replace this test grade with your test number 2 grade. So this test number 2, this test number 1 grade can just completely disappear. So you have one more opportunity to show me that you know how to do the stuff on this test, and that happens on test number 2, okay? It doesn't happen for test 3 replacing test 2. It's only this one right here can get replaced, but I just want to put it out there. Okay, so the answer key for, I have my solutions to this test right here, so you can grab it now or later on if you want to, just if you want to take a look at it, let me know. And also, the answer key lives in the same 2 places that the answer key to all of our quizzes and tests will live, in the Math Studio and in the library. All right, so we begin with class packet number 2, and I just want to point out that let's see, we'll take our quick look at the schedule. This is one of the very few days during the semester where there is no homework due. Today we'll cover lesson 12. Isn't that fun? And then the very next class, homework 1.9 will be due. And I want to point out now in the homework page that 1.9 is on the next page. So this is the green homework assignment sheet. Right, so we've already finished that one page. We're now moving on to the next page. So the assignment due next time is right there, 1.9. Everybody see it? Yeah. Now you have no homework for next time. Okay. All right. So class packet number 2 looks like this. The table of contents is on the very next page. What's kind of funny looking about the table of contents? That's unusual. It starts at page, yeah, it starts at lesson 8 and it starts at page 58. And in fact, if you turn the page, grab one from that table right there. Yeah, so the page numbers here don't match up. Well, the pages here will match up as soon as we turn the page. So it's kind of unusual, but what I can't read it. Is that a 93? Yeah. 93. Where's page 92? You have already seen page 92. Where was it? It was in the other blue packet. All right, so we've got 3 blue packets. Essentially, it's one big book, but we're just giving them out in thirds. So this one starts on page 93. Okay, let's see. If this course feels too fast or difficult, it is still possible to switch into Math 094, which was a course in between this one and the Math 090. So you can talk to me about details if you are interested. And then we've talked about this heads up several times. We have kept negative numbers away from the algebra. They are coming very soon. If you are still uncomfortable with negative numbers, it is time to take action and fix that before you get swamped with them in the midst of all the algebra that's coming up. Let's go down here to this objective. Can we start with Lily? Thank you. Dwight? Okay, so can you guys individually and then as a group come up with some translation to that sentence? Add 5 and 7 and then multiply the result by 2. No variables, only numbers. Let's see if you can translate that into symbols. Okay, so we have 5 answers up here. Only these 2 on the left are exactly the same as each other, and the other ones, so essentially we have 4 different answers here. So thoughts? Add 5 and 7, then multiply the result by 2. What do we think about this one right here? 1 vote for it works. Add 5 and 7, and then multiply the result by 2. There's nothing in this problem that says explicitly use parentheses, but somehow the group that came up with this answer decided to put parentheses. Which group did this, or either of these? Here and here. So what did you guys see in that phrase that said bring parentheses in? Okay, so that phrase, the result. In order order to change the PEMDAS rule, use parentheses. So how does that seem? So compare that to this one over here, which also has parentheses, but in a different place. Are they equivalent to each other? Yeah, if we look at this one here, this would say do the multiplication first. And I think Dwight said it perfectly, is that we need to change PEMDAS because this problem is telling us to kind of do something different than the normal PEMDAS would do. So this right here seems reasonable, just reading, like translating words to symbols, but we have to change what PEMDAS wants to do, and we do that with the parentheses. So I think that's a great explanation. What about this one here? Okay, so there's no dot for multiplication. Is multiplication implied when there's no dot like that? Yeah, parentheses imply the multiplication. That looks good. I see two other differences between these two answers. The 2 comes first. Does it matter? So it might matter? Yeah, we'll talk about distributing. Well, I guess my question is, is this answer, we've already decided this one is okay. Is this one okay? The 2 is on the other side. Is that okay? Yeah. And there's a fancy rule for the fact that you can multiply 2 numbers in either order and get the same thing. How much is 3 times 4? 12. How much is 4 times 3? 12. So putting the 2 at the beginning or putting the 2 at the end makes no difference. The fancy rule, I'll put it here. You don't need to know this word for this class, but it's the commutative property. And you can see the word commute there in the front, which says things can travel around and it doesn't make any difference. Okay, but there's even one more difference besides just the 2 being in the other spot. What else is different? Carolyn? 7 and 5 are reversed. Here it's a 5 plus 7. Here it's a 7 plus 5. Are they the same? Yes. So does it make a difference that they're reversed? No. What's the name of that property? It's still the commutative property. There's a commutative property for multiplication. 3 times 4 is 4 times 3. And here's an example of the commutative property for addition. 5 plus 7 equals 7 plus 5. So they're exactly the same. They're both right. They're both full credit. I will just say one thing, that if we are trying to exactly translate the phrase as it is, add 5 and 7, all right, the 5 and the 7 are in that order here. They're reversed over here. And then multiply the result by 2, it feels like the times 2 like technically belongs at the end, but it makes no difference. And they're both right and they're both full credit. But if you are trying to translate things, I would encourage you to just translate them as you see them, as opposed to, like, it just feels like there was work involved in doing this. And when you're doing more work, there's the opportunity for more error, and there's no error in this problem, but there's the opportunity. So I would just translate it as I see it. I would feel naturally to go here. All right, what's going on here? 5 plus 7 is 12 times 2. Is that a true statement? 5 plus 7 equals 12 times 2? It's not. 5 plus 7 is not the same as 12 times 2, but that's not what the person meant. What did this person mean? Yeah. That's right. So 5 plus 7 is really 12. So doing that like as a separate step, and then multiply the result by 2. How much is 12 times 2? Is 24, which is exactly the same as all the other right answers up here on the board. But if we are looking to translate things, we really want to translate. And we don't want to do any of these like intermediate calculations on the side. We want to be able to just write it down in symbols. Yeah, without an equal sign. That's right. Another good point is the word expression here. Where is it? Here we go. Yeah, expression and equal signs don't go together. Good point. Okay, any questions about this idea of translating? Okay, on the next page, you will find the classwork. So work with your neighbors. I'll put the flags out and let me know if I can help. Okay, so can you guys all jump back to page 94 with the rent and utilities problem? So there's this full class activity that didn't have instructions. So now I'm going to provide you the instructions here for part E. The instructions are circle all of the expressions here that correctly represent the answer to part A up above. More than one of these things is an acceptable answer to 1/3 of the sum of rent and utilities. So see if you can find all the ones that are right. Okay, let's talk about these. How about part A? Is that okay? No. What does part A do? 1/3 of what? 1/3 of only R, but not 1/3 of R plus U. So A is no good. What about B? B is okay. And in fact, some of you guys wrote down B as your answer all the way at the top of this page. This is saying take the sum of the rent and utilities and divide by 3, which is the same as taking 1/3 of the whole thing. Somebody had asked, Sarah had asked if there were implied parentheses here. Yes, absolutely. So if you put parentheses by the way you read the problem, it's okay that you don't see them here. We know that that division symbol kind of implies parentheses upstairs. Okay, next one, R plus U divided by 3. What's the problem there? It's just taking utilities and dividing by 3 instead of both of them added together. How about part D? Yeah, D is fine. And in fact, I would argue that D is the most natural way to translate what the phrase says up above, 1/3 of the sum of rent and utilities. B is totally fine, it's full credit. But it, to me, I would have written D when I saw the problem. E? Is E okay?
Yes.
Yeah, E is fine. In fact, this kind of gets back to Sarah's question. If you have implied parentheses, then you can use this slash as the division symbol as long as you put those parentheses in there. So E is perfectly good. F. F is no good. R plus U divided by 1/3, that's not okay. Should have been multiplied by 1/3. What about G, R plus U divided by 3? Yeah, that one's fine. And in fact, parts G and E, these two right here, they look exactly the same. All we're doing is trading the slash for a division symbol. They both mean divide. So they're both okay. And then the last one, H. No, again, H is only taking 1/3 of the R. H is the same as which other one, which other wrong answer up here? Is H the same as C or? H is the same as A. It's taking 1/3 of R. And one little thing here, if I just look at this, it sure looks to me like that's a 3R. So is this the same as 1/3R plus the U? Looks like 1/3R. What did I do wrong? Yeah. If I follow the order of operations, I have a, yeah, I shouldn't be multiplying 3 by R. I should be doing the division first. 1 divided by 3, that's a number, and then multiply the answer by R. Okay, moving on to the next page. There's this problem which a bunch of folks have made some progress on. So I just want to point out that so if you can answer parts A and B without using a table, then that's fine. Some people are just going to be able to get this and they can see all of the relevant data and grab what they need from this problem. Other folks, myself included, need a way to organize a lot of data when the problem is involved like this one is. And we're going to be doing a ton of problems that are just as involved as this one is. So I'm going to give you a table that you are perfectly welcome to use but not required to use, okay? So let's just work through the table, and if you feel it helps you personally, then do it, and if not, do the problems without. So not mandatory. But here's what's going on in this table. This first row, we're going to fill in the number of something, number of books, number of CDs, number of items. When it says items, that means all together. In the next row, we're going to write in the cost of one book, the cost of one CD. The cost of one item is not applicable. There's 2 different items. Everybody understand this up arrow or the upright arrow is kind of generally pointing to the things in the top, the books and the CDs and the total items. And then the last row is the cost of all books, the cost of all CDs, the cost of all items. So here's what I encourage you to do if you're going to use this table. Don't try to look at the blanks in the table and find the numbers to put in there from the problem, but look at the problem and figure out where to put the numbers. I think that's a much better way of using the table. So the first relevant thing that I see is she bought a total of 29 books and CDs. That is telling me a number of something. Number of what? Is that a number of books, number of CDs, or number of items? That's a number of items all collected together. So right in here we put 29. 29 items all together. Next piece of the puzzle. Each book costs $25. Which row is that? The second row in the green, the cost of one book is $25. If you keep reading in this problem, what does it say about CDs? They're $10 each, so put $10 in the right blank. That's the cost of one CD. Okay, and then the only other thing here it says is X stands for the number of books. X is the number of books. What row is that? Top row, number of books is X, so you put an X right there. Okay, so now let's see if we can fill in some other stuff for this table, but we can't fill anything else in based on what's given in the problem. So we have to do some work to figure out what goes in the rest of the blanks. That's right. So the first thing is this number of CDs. We have 29 items altogether, and X of them are books. So the rest of them are CDs. And how do we find the rest? We subtract. And if it's difficult for you to understand 29 and X should be subtracted to put in this blank, then just pick your favorite number for X. Suppose that you bought 10 books. How many CDs did you buy? 19. You know automatically, you just do 29 minus the 10 books. That's how you find what's left over for the CDs. So we do that same thing here. I'm putting it in red because it's not coming directly from the problem, but it's something we're figuring out on the fly. Okay. Let's see if we can work on this bottom row here. So in this first column, it's talking all about books. How many books did we buy? X is what it's called. How much did each book cost? $25. Do we know what to do with those two things to find the cost of all the books? It's multiply them. It's multiply. And if that doesn't feel natural to you, again, pick your favorite number for X. Let's say we're still buying 10 books. If you buy 10 books and they cost $25 each, how do we figure out how much we spent all together? So we multiply them, right? $25 times 10 books, $250. So in general, we multiply. 25 times X. Now the fact is you can play the same game here in this next blank. You can multiply in that next column. We're actually not going to do that today. I'll just say soon. But if you have the confidence, you just do the same thing. Multiply straight down. And then in this last thing, the total cost of all items is not quite as soon as the first one, but it's coming. So at some point, very soon, we'll have that whole table filled in. For right now, it's just as it is. Okay? So again, completely optional whether or not you want to use the table. But if you've got the table filled in like we do, it is now very easy to answer both questions that are in this problem. Okay, so keep working in your groups.